Okay, so I decided here with the notes that I do two separate little chunks here with two separate OTIs because technically it's supposed to be 2 days worth of work. I didn't really want to make like one giant video and one giant assignment. I think it works better in chunks here. So 3.1 is about graphing polynomial functions. So yeah, we talked a little bit about polynomials in the warm up there with standard form and everything. So hopefully you got that. Learning target for this is the main thing is going to be I can predict the behavior of polynomial functions. So the big idea here is you can obviously put these in a graphing calculator, graphing app, graph them and take a look at them. But what you should also know is what they're going to look like before you do that. You should have an idea of what you're going to be dealing with for a lot of reasons that you'll see as we go forward through this. So the first little problem here, this little explore and reason thing, which for some reason is just blurry when I printed it. Maybe the picture wasn't great, or I'm not sure why. Sorry, but it basically is talking about here when you graph different functions of x to the n, like x to the first, second, third, fourth, fifth, and so on. The graphs all look different. Now, if you just graph it for first, third, and fifth, so like your first three odd numbers, so x to the first, x to the third, x to the fifth, the graphs are shown here. So you should know what x to the first looks like. That's linear. That's just y equals x, flat line. X to the third has this shape here. And then you'll see x to the fifth is kind of the same exact shape, but it's a little steeper. As you would expect, it's going to increase faster than an x to the third will. And so it says here, as the exponent increases, what's happening to the graphs? So I kind of already gave it away. The graph's essentially increasing faster because, linear, the x to the first was here, x to the third here, x to the fifth, a little narrower. So they're all getting a little bit steeper, okay? So what's happening to the graphs? Well, I'm just going to kind of say the word steeper here. We kind of talked about it. But that's the big idea. Also, it says, which quadrants do the graphs pass through? If you don't know your quadrants, you definitely should. Where x and y are both positive is quadrant 1. And then going around counterclockwise, they're named 2, 3, and 4. So in this case, these graphs are always in the first and third quadrant. All right, so now it says, what happens when you do it in the second, 4, and 6 powers? So I'm going to use my calculator for this, but obviously you could use, decimals, whatever. But I'm going to go ahead and type in x to the second, the fourth, and the sixth all into here, and we'll take a look at what we're dealing with. Okay, so there's my three functions. I'm going to graph them. So we know what x squared looks like. That's our parabola. There's x to the fourth. And it's a little hard to see, but you can see it just did it right over top of it. X to the sixth is that same shape, but narrower. So if you're starting to notice kind of a pattern here, is really all these even ones are going to keep the same shape, but they're just going to get steeper and steeper and steeper. So it says what happens to these graphs in quadrant 1 as the exponent increases. These also get steeper. Sorry. And which quadrants do these pass through? So these are always living in quadrants 1 and 2. So just from those two little parts there, the takeaways from this should be, okay, odd powers are in quadrants 1 and 3, and as the power gets bigger, the graph gets steeper. And even powers are in quadrants 1 and 2, and same thing. As the power gets larger, the graphs get steeper. Okay. Write two equations in the form of x to the nth with graphs that you would predict that would be in quadrants 1 and 2. Okay, so if they're going to be in quadrants 1 and 2, they've got to have even powers. So for that question, you could say like x to the 8th, x to the 10th, 12th, so on, would all work. And then how would you get them to stay in quadrants 1 and 3? Those would have to be your odd powers. So that'd be like x to the 7th, x to the 9th, 11th, 13th, so on and so forth. Obviously, we can check those. If you want to see what does an x to the 8th look like, you can throw it in here. It should be in quadrants 1 and 2. Boom, it is. If you want to see what x to the 9th looks like, this should be in quadrants 1 and 3 because it's odd. And there we go. So we're getting the same idea. What you notice is it does definitely get steeper. In fact, as you get to a lot higher numbers, like let's say you did something crazy like 101, so a really big odd number, it might even be so steep we can barely see it. Yeah, see how it's almost like straight lines completely? And again, that's what you're going to see as you mess with these shapes. It's kind of a sort of major concept going forward. All right. So let's move on to this very first example. It says, how do you write a polynomial in standard form and use it to identify the leading coefficient, degree, and number of terms? Okay. So standard form we already talked about in the warm-up. That's where we're going to go highest power of x down to lowest power. So in this case, the standard form is 2x to the third minus 4x plus 9. Highest power first, and then in descending order with the constant term last if there is one. Now it asks about the leading coefficient, the degree, and the number of terms. Leading coefficient is kind of an obvious thing. It's the coefficient on the leading term. So once you're in standard form, this is your leading term, and therefore the leading coefficient would be 2. Okay. The degree. So the degree is the highest power. So your degree is what is the highest overall power, which is 3. And these do have names, so we're going to write this. So we can call this third degree, which also is called cubic. So in just a second, I'll list all your different names. Some of them you're going to already know. Some of them might be new to you, but we'll make a little chart of those in a second. And then lastly, number of terms. So this is also pretty easy. Sorry, I should say number of terms. Number of terms is how many things are separated by plus and minus signs. So this has 1, 2, 3 terms. These also have names. If you have 3 terms, it's called a trinomial. So give me just a sec here. I'm going to make a little chart to go over with you. Okay, so off to the side here, I'll talk through them, but I made a couple little charts, and you can pause it and copy them if you need to, or whatever. But talking about different degrees. So again, degree is whatever the highest overall power is. So if the highest overall power is 0, that means there's no variables at all. So it's just a constant function. It's going to be a flat horizontal line. If the highest power is 1, it's going to just be an x, which is what we've learned a long time ago, linear functions. If the highest power is 2, it's quadratic. That's the entire last chapter we just did. And now we're going to start getting into the newer stuff. If it's the third power is the highest overall, it's called cubic, like cubed. If the highest power is the fourth power overall, it's called quartic. And then every other one actually does have names. Like fifth is called quintic, and sorry, 6 is called, you can either call it hectic or sectic. There's 2 different names for it. But there, if you want to look them up, there's charts for all of them. But really, once we start getting to 5 and higher, we just call it 5th degree, 6th degree, 7th degree, and so on. Yes, they do all have names. Like I said, you can look them up if you want to know them. But these are really the most common ones that you're going to see a lot of. So you should definitely know those names. In number of terms, so we said trinomial a second ago. If something has 1 term, these are pretty easy. It's called a monomial for 1 name or 1 term. 2 terms is called a binomial for 2 terms. 3 is trinomial, 3 terms. And again, there are names for 4 and 5 and 6, like quaternomial, quintinomial, so on. But we just call them all in general. Anything with 4 or more terms, we just refer to as a polynomial, basically saying it has a lot of terms or many terms. So these are kind of your general names. You're going to see these used a ton throughout this chapter. So you want to make sure that you know them and that you can explain them. All right. So if you want to pause for a second, see if you can do the same thing with these 2 polynomials here, and then I'll go through and explain them. Okay, so let's run down the line here. So I put it in standard form already. Again, highest down to lowest power. Make sure you keep the coefficients with it. Once you're in standard form, leading coefficient, super easy. It's the coefficient on the lead term. So -3 would be the leading coefficient here. What's the degree? Highest overall power is 4th degree, which we call quartic. Number of terms, this has 4 terms, which we just refer to as a polynomial. Okay. Same thing down here. Highest down to lowest power is standard form. And then leading coefficient would be 2. The degree would be 6th degree. Number of terms, there's 5, so it's just called a polynomial. Okay. So hopefully that feels pretty good. Again, this naming stuff is really key going forward. So definitely got to make sure you know it, but it's not particularly difficult, really.